That's right. I played the wrong theme there for a moment. It's still sitting right there in my little clicky window file. Hello, welcome to the show. It's me, JP. It's time for John Park's Workshop here on this sunny and hot Thursday afternoon here in Los Angeles. Thank you everyone for stopping by. And by stopping by, I mean, hey, thanks for watching, first of all, and also thank you for joining in on the various chats. By various, actually, I mean two. So we've got our YouTube chat, which I'm keeping an eye on, and we also have our Discord chat right over here. So if you're somewhere else and you're wondering where all the conversation is, you could check out our Discord server by heading to adafruit.it/discord and look for the live broadcast chat channel. That's this one right here. We've also got a whole bunch of other channels. You can see them right here as I scroll through them. We've got pet photos, we've got help with CircuitPython 3D printing, Arduino audio, projects, general project help, super great place to go with questions or to help people out. CircuitPython dev, there's even a tagged thread in there for SynthIO feedback, if you're into that, and on and on. So yeah, all the chats. Excuse me. All right. So that's the Discord. Go check it out. But also, I want to thank Quinman16 and Dave Odessa and Is This YouTube and Randall Bone for stopping by over in the YouTube chat. Thanks for jumping in. And let's see. Let's get on with it. So what have we got today? First of all, I've got a coupon code for you. So if you want to go to the Adafruit store and pick up some great stuff and maybe get yourself 10% off discount on the way, then when you're checking out, type that right there into the chat, or rather into the coupon code box. That is today's coupon code. I don't have any idea how to pronounce it. It's the name of an IKEA product, and it's something we'll be working with today. I think I looked, and the only pronunciation guide that showed up was in Danish, which probably is fairly close to the Swedish one. Mopi, I think. Mopi is how the computer on the Google pronounced it. But anyway, M-O-P-P-E, Mope, Mope, Mopi, however you want to pronounce it. You can use it by typing in M-O-P-P-E in the coupon code field on the way out. That'll get you 10% off on anything you buy, your whole order. It won't work on gift certificates, subscriptions, or software, but it will work on stuff, physical goods, things. So go get some things. You could head right over here to Adafruit.com. That'll take you right to the store. You can see here we've got links at the top for things like products. That'll take you to the new products, feature products. You can go by categories. You can just scroll down and see what's what here, some banners and things. Go get yourself some good stuff and use that coupon code on the way out to get a nice discount. All the things. Andy Calloway asks, what happens if I try that coupon code in IKEA? Collapse the universe. Don't do it. All right. Also, I will give you a little recap of my Tuesday show. That's it right there. That's JP's Product Pick of the Week. I do that on Tuesdays at this time, which is 1 o'clock Pacific, 4 o'clock Eastern time. During the show, I show you some new product, or sometimes oldie but goodie from our archives, that I give you a huge discount on. And by I mean we, the team, particularly new products team, Jelly. Thank you everyone who makes that happen every week. We gave you this one for a whopping 50% off this week. It was this mini I2C GamePad. Here's a little 1-minute recap. It is the GamePad QT. It is a Seesaw chip-based Stemma QT connected GamePad. It has the 2-axis joysticks, that's an analog dual potentiometer right there, as well as the 4 ABXY buttons and start select. GamePad QT plugged in over Stemma QT cable to the Featherboard. If I want to move my servo arm there that I happen to have connected a Neopixel stick to, I can just move that analog LEDs to different colors, so I can set those to red or yellow, green. Some steering on one axis, and I want to do some speed stuff on another. You can see I can set the speed variable speed on the DC motor there using that little thumbstick. So it's just a ton of I/O all in one place. Great for robotics projects, as you could tell there. It is the GamePad QT. All right, let's see what else is going on. There was a super cool guide, by the way, that Phil B posted. Let me jump over to Learn Guides here, and this is related. This is actually related to that product pick there, I think. So this is the NES Emulator, Nintendo Entertainment System Emulator for RP2040 DVI boards, and a super great guide. Phil put 3 different ways to do it. So there's a Feather RP2040 DVI, which is actually what I'm using back here to do my little video art display, a little sketch from Toddbot there. This has an option on this version to use the I2C GamePad WeChuck adapter, which lets you use stuff like these Nintendo Wii Classic controllers. It's upside down because they have that WeChuck adapter form factor there. And it's actually a gamepad happening over I2C. So I actually wondered if what it would take to actually make our little gamepad, which is also an I2C gamepad, work with this instead for a super compact and not very ergonomic version. And given the way that Phil has this laid out, I think you could probably even plop that onto the Feather tripler there. And I believe the gamepad has the same footprint. It doesn't have the same pinout, but it does have the mounting hole footprint, so you could probably attach that there. Pengu, does that actually emulate NES on RP2040? It does. It's incredible. It really does. In fact, I put a little demo video together. You can see it right here. It does have sound, by the way. I know Lamore wasn't sure. She mentioned this guide last night. It does have sound. You can probably hear it there a little bit. So that right there is happening on Pico RP2040, but this runs the same on all 3. And it's a big group project that spanned many different GitHub repos. We got it from Frank Hodemaker, but his came from Jay Kumagata and Shuichi Takano and Luke Wren. So there's about a bunch of collaborators. Phil B added controller support, ported it over to the Feather. So there's a bunch of people who've worked on this. But yes, it is a NES emulator, works great, outputs over DVI HDMI port, audio and video, and looks great. It is crazy what people do with the RP2040. Also, hello, Johnny Bergdahl. Maybe you can help me with this. Today's coupon code, I don't know how to pronounce it. It's an IKEA product. We're going to show it later because I'm using one. If you can write phonetically and we can figure that out, how the heck do we pronounce that? I think I saw a Danish pronunciation online that said it was Mopi, something like that. Anyway, that'll get you your 10% off in the store today. Check out Phil's guide because you can get most or all the parts you need to use the Feather version of that. If you have a Wii controller, you can use our WeChuck adapter. You can also use a USB controller if you don't want to, although it's not as lag-free as the shift register real Nintendo controller versions of that. All right, I had a question over in the chat I wanted to address. Quinman16 said, how's it going with the PyPortal update? And I do not know. That is why I didn't answer that question. I know you asked a couple times. That might be a question for Lamore on Ask an Engineer, so maybe check back on Wednesday. Not sure if that's the ESP32S3 version. I thought maybe she talked about that on Ask an Engineer last night, but if anyone knows. Mop followed by an E, says Johnny Bergdahl. Moppy. Moppy? Moppe? Short for moped or mopped. Mopped? I don't know. It's going to get butchered by me. I'm so sorry. Let's now jump into a CircuitPython parsec. All right, let me grab my coding window here. For the CircuitPython parsec today, I wanted to show you how you use Neopixels inside of the Circuit Playground library. So the Circuit Playground library is a high-level library that gives you access to pretty much all of the sensors and outputs and inputs and things that are on the Circuit Playground Bluefruit and the Circuit Playground Express boards in CircuitPython, but with a very easy to use library. So this one I have set up to light up Neopixels in a couple of different ways. And the way it's done here, you can see in my code, is I'm importing from Adafruit Circuit Playground CP, that's the Circuit Playground library, and then I don't have any setup necessary. Normally you'll have to do some setup on some Neopixels if you're using straight up CircuitPython. In this case, it knows what board we're using, so all I have to do to call the Neopixels is, if I want to light them all up, I use this cp.pixels.fill, followed by an RGB color value here. So in this case, 20, 0, and 5, red, green, blue, and that gives me this sort of pinkish fill color that you see at first when they all light up. Then, since I've imported time, I can sleep for a couple seconds, turn them all black, sleep for another couple seconds, and then this is the other way that we can light them up inside of Circuit Playground library. I'm saying cp.pixels, and then in brackets, I can pick any number 0 through 9 of those 10 Neopixels and give that one a specific color. And that's why we can see a little cyan one and then a yellow and a pink one lighting up at the same time there. That's because I'm saying, okay, for the Pixel 3, that's the fourth one down here, we'll light that up with 0, 25. Then I light up Pixels 7 and 9 with their own colors, turn them off, and then loop that process. And so that is how you can use the Circuit Playground library in CircuitPython to very easily control Neopixels. That is your CircuitPython parsec. We have one suggestion from the peanut gallery there. Steve said, what if you do cp.pixels.fill? We'll try that. By the way, this is another nice thing about this library. You can see here in my REPL, I have hit Control-C so I can get a prompt, a command line prompt. And now I can enter in CircuitPython commands directly to the board. So if I do, let's say, from Adafruit Circuit Playground import CP, that's going to import the whole Circuit Playground library. And now I can do cp.pixels.fill 000. That'll clear them. I think that needs to be a tuple, actually. Now we can light up individual ones, or we can try Steve's idea, which is fill. It does not work. We do not have fill spelled like the name Drat. Also from the Discord, here's another idea. We can do specific ranges of pixels. So if we do bracket, let's say 4:8, close the bracket, oops, equals, let's do green, 0, let's say 40, 0. These go up to 255, but that's very bright. Oh no, I can never remember. How do I? Now I've done it. Well, that was going to be so cool, except how do you escape the darned? I thought double return. Someone remind me, how do you get out of that? I don't know how to get out of that. We can put that up into code, however. So if I hit Control-D, that will start running the board again. So let me just get rid of some of this code up here. And I can simply, oh, did I use the wrong bracket? Was that why? Oh yeah, I had a parenthesis. I made a boo-boo there. But that's okay, we'll do it right here. So if we do cp.pixels bracket, what did I say, 4 through 8, close the bracket, equals, oops, and hit save. That will light up just pixels 4 through 8. Unmatched number of items. What did I do wrong? cp.pixels equals. Does it not want a tuple there? Unmatched number of items on RHS. Expected 4 got 3. What does that mean? That's what happens when I start winging it. No idea. That should work, right? Let's do just one of them. Probably doesn't like me do this. By the way, if you're trying to test just a single line like this rather than looping it, you can do while true pass, and that'll should just light them up and then do nothing. Should not need RGBW. That would be weird. All right, so let's try 4 through 8. No, what is this RHS business? Right hand side. All right, let's put a 0 there and see. Huh. That's weird. I don't know what's going on with that. All right. Maybe we'll make that into a Circuit Python parsec when I figure out what the heck is actually going on. 4 through 8 should be 4, 5, 6, 7. Oh, it wants 4 colors. Oh, that's interesting. Yeah, it won't just loop them, huh? Fascinating. All right, we'll play with that another time. Okay, so let's get back to this project that I started to show last week. Thank you. Tyth says it wants the same number of tuples as array elements. That makes sense. Thank you. Let me jump to my Chrome window here and hold on one second. Okay, so this was the project that I kicked off, I believe it was last week, and the idea is to make a simplified build of this ambient machine. And so the idea behind this is that we have all these great toggle switches here that allow us to turn on looping samples of things like a long, evolving piano line with lots of reverb, or some sounds of water or white noise, to create a nice background ambience where you can flip these switches to decide what you want your custom sound to sound like. This version by Yuri Suzuki has I believe a custom PCB. I'm not sure at all. I don't know any info about what the board is like in there, what it's how it's working. I believe it's sample based. It's not synthesized. And so we need essentially a mixer in software. We need samples. I'm going to use WAV files because they stream pretty quickly off of SD card. And we're going to have, just like this, a amplifier and speaker built in. If you look at, I believe there's a nice picture of the back of it. So I can open that image. So this has this beautiful walnut case for it. You can see there's a sort of speaker grill on the back there. I believe it's just an on-off switch and a power over USB on the back there. So that's the idea, and what I'm planning to do is build this with the new Metro M7 and a SD card reader with the WAV samples on it. and then maybe a diode matrix of switches or an I/O expander, so that I can have a lot of toggle switches. Unlike this version, which has, I believe, 32 switches on it, it's an 8x4 grid. I'm going to make mine a little smaller, and that's partly because I wanted to use a almost ready-made box solution for the cabinet of this thing. And that's where this comes in, this mope, anyway, this IKEA thing. You may have seen these before, you may have one of them. These are about $30 at an IKEA near you, and they are these Baltic birch plywood drawers, and you can see they have a sort of chipboard bottom on there it's got a little bit of wiggle to it, which is actually kind of interesting because that means we could potentially slide a template into there if we wanted to use some colored plastic or paper. So I took some construction paper, cut it to the same width, but and I made a little error there on the side. I think it's a little too small, but it's a little longer on the top and the bottom, so it kind of curls and pops into place there. So that's one way to get a kind of nice looking bottom. I don't want to deconstruct this. This is finger joints, lots of them. It's been glued. There's no good way to pull that apart. So I'm not getting that bottom off since it's got a little routed groove. And in fact, you can see that's the routed groove there that chipboard bottom slides into during assembly. And these are pretty neat. One nice thing about them is that, you know, they're designed to be simple little storage drawers, but since they have the same finish on the back of the drawer as they do on the front, if you don't want this little finger pull here, you can repurpose these, paint them. There's a lot of modifications people like to do with these online. If you look just at IKEA mods, you'll find all kinds of things where people have added drawer pulls by flipping them around to the back side. People have painted them, stained them, added other hardware for things like card catalog type of look for little labels, stenciling them, and on and on. They actually take stain quite well. I haven't tried it, but allegedly, and watching some videos on YouTube, sometimes Baltic birch finish doesn't stain very well, but these appear to stain quite nicely. So I think I may go ahead and stain mine sort of a darker walnut or cherry type of color. And you can see lots of people stacking these up, turning them into giant pieces of furniture, which is pretty funny because, you know, they're humble little. Oh, there's a nice wall-mounted one. These came in different sizes. This is the current one with these large, medium, and small 1, 2, and 3 drawers in them. So that's what the thing looks like there. That's what you get, a bunch of drawers. So for $30, it's pretty good. It's actually quite a bit of Baltic birch plywood for the price. I don't know if I could buy it and laser cut these myself much cheaper than just getting these. And so my idea with these, let me jump to, 1 second, how about that view right there? That'll work. So one of my ideas with these is that we can use that existing chipboard base there and drill it out for all of our switches. So here I've got a big pile of these little toggle switches. We're just going to use single pole, dual throw switches, the narrow ones, and we'll be able to run with this ratio. I think a 5x4 grid will work nicely. And my idea was I actually really like the ratio of the medium drawer. So do apples to apples there. There is the small drawer next to the medium drawer. I really like this ratio. It's very similar to a 4x3 television set kind of ratio. I like that. Means it's not quite as direct a design ripoff as the original. You could potentially use the largest drawer depending on your, what do I have in there? There's something blocking it. Depending on your speaker that you want to put in there, how much space you want, you could do a massive, probably 12 by 8 or something like that switches, depending on what you need. I'm going to leave that one out of it though, and use this box. And what I did was I went ahead and made an array of circles with some center guides. And what you could do, I actually cut this a little, I need to cut that a little smaller so that it fits precisely. What you could do is just tape that down and go ahead and tap a little starter point or pilot hole and then drill those out carefully. And off you go, and then maybe you could add your paper template or paint it, mask this and paint it. I went and went an extra step with that and used the laser cutter to cut that out. So first I did a little test on a little piece of cardstock there. So I have my little guide, and that's how my little toggle switches will fit through there. And with that confirmed, I went ahead and did a cut on one of the boxes. So now if you take a look, we've got, this one still has its hardware, so it won't poke very far through. But we now have a pretty nice, grab one with no nut on it there. There we go. We have a pretty nice fit there. We can screw on the little hex nut there and get those all lined up. A bunch of toggle switches for our ambient synth. We've got plenty of room in the back, which is nice, to do our speaker, amplifier, microcontroller board. One idea I had about this, though, since it would be nice to get a bit of a resonant chamber speaker box type of thing happening in the back here, and I didn't want to go and get extra material, is what if I use the small size one, which actually fits nicely over that pattern. You can see here, that pattern actually still fits inside of there, so I don't think I'll bump into any of my switches. So this will fit over here like so, and I can have a little wiring harness coming off of these that'll plug in. The rest of the electronics can be mounted in here somewhere, and then I can again cut, drill, slice speaker holes out of the back here somehow, and attach the speaker to it, maybe even put some cotton batting in there, some stuffing in there to reduce vibrations, but get a nice bassier type of resonance out of that. And then that would go in here somehow, maybe on some little risers, screws, not sure. But so obviously it's not going to look like the art gallery piece of the original, and it does stick out a little on the back there. You could cut this on a table saw to get that flush. I probably won't for the purposes of this guide. I want to keep it simple. I'll use the laser cutter just to make it look neat and easy and repeatable, but it would be, I think, totally doable just with a drill press or a hand drill. And then what's left after that is to add some nice little feet to it. So I didn't find anything at IKEA. I was hopeful I might find something that, a drawer pull or something that would work well. But the design I wanted to do was to kind of keep with this mid-century modern type of styling. So what I have started with is just, again, direct rip-off of the original, sorry to say it. So if you look here, I'll show you what this is looking like in side of Rhino. And I can show you how I put this together. So if we look at a top view here, I started with a measurement of just the exterior of the medium drawer. And then I also measured the plywood, which averages to about 6.2 millimeters. I think it was 6.25 millimeters. So let's look at so there's my main curve, and then I'm making an offset version of that. There we go. So you'll see that the things that I'm picking here are the when they light up green, those are the nodes kind of traveling through the flow of the build here in Grasshopper. So I'm extruding both of these and using one to cut out the other to make sort of the basic box there. I'm also cutting out that little channel groove so you can see that's where the little chipboard backing lives. And then I took a point, I actually just started from the origin down here, since this, I built the original curve starting at that origin, and I went and created a rectangular array of what my holes will be, and those just get lifted up and cut out of a base there. So this is what my model looks like so that I understand the space of things. You can see here I've also added in sort of simplified version of the legs. These are only angled on one dimension. I think in the original they have a diagonal here. But that gives me something that I can kind of verify the design with. If we take a look at a rendered version there, that's what I used to visualize it, and then I just really needed that set of circles and the reference point of one of the corners to know where to print or laser cut, print a guide for drilling or laser cut. So the next step for me will be to also model in the smaller cabinet, design the holes that'll be cut out of the back of that for the speaker, fit the parts into there. That's one of the things I really like to do, especially because the Ruiz brothers build so many of our parts. You can get a Metro, you can get a add-on board, you can probably find one of our speakers or just mock up the dimensions and the whole guide for how to drill that in there. And that lets you really visualize how the thing will fit before you go and start cutting things up and drilling things. So that's where I'm going with it. I think these feet, you could just probably take 3 layers of some plywood or other wood and cut them and glue them together, or glue them first and cut them, or take a little chunk of oak or something like that. So those will be pretty straightforward, and maybe just pre-drill the tops of those and some little holes in the case there and just screw them in from the top. It doesn't have to be anything too fancy. So that's the progress on that and the idea on that. I just started to put together a fritzing diagram of my Metro M4, or rather Metro M7, to connect it up to a SD card. Now, I can't remember if this is a new, don't ask, don't tell, but a little birdie told me we may have an SD card version of a Metro M7, kind of like the Grand Central. And if you know, the Grand Central has the SD card reader built right into it. I think it can run over SDIO super fast. There's possibly something like that in the works on the Metro M7, which means eventually you wouldn't have the additional breakout. But for right now, I'm going to use a breakout version of that right there, which is our little SPI micro SD reader, and that'll actually interface almost entirely with the SPI pin set that's down here other than 3 volt. This runs on 3 volt, and that pin I think is 5 there. But with those, I should be able to stream the WAV files off of here and mix them. What I need to figure out is actually what the mixing strategy is of the switches, looking at the original, and we can do it our own way, but I believe we could potentially just limit it to 5 sounds, just which of the piano sounds. There's, 1, 2, 3, 4 of those. There's 1, 2, 3, 4 water sounds. There's 1, 2, 3, 4 chime noises, and so on, and just pick the ones, or do we mix a bazillion of those all at once using Audio I/O and Audio Mixer inside of CircuitPython? It should be possible. Mostly comes down to, I think, how fast we can get the WAV files off of here. Since it's going to be probably one of these, do I have one right here? No, I've moved it. Probably be one of our 3-watt 4-ohm speakers that are about that big. I don't know where I lost one to. It's mono, so I can get away with mono sound, which is great. Kind of cuts in half the data requirements there. And probably Lamore was suggesting like 16 kilohertz, or maybe even lower sample rate to keep the wave requirements lower. Let's see, questions. AT Makers Bill says, why Grasshopper instead of Fusion? What are the pros cons? I think I've talked about this before. I mean, Rhino is a NURBS modeling, surface modeling program, which now also has sub-Ds and T-splines and other things. So it's a hands-on modeling program, very different. There's not so much in something like a straight CAD package like Fusion or SolidWorks. There's less of the idea of you hand-clicking things and mushing them around. So Rhino does that on its own, but then Grasshopper is the parametric modeling add-on that lets you use any of Rhino's features, but from a flow graph. You can add little bits of Python code and other languages in some nodes, so you can use it for parametric stuff. It's used a ton in architecture for parametric designs, which is cool. I know it, and I've used it for a long time as one of its advantages over Fusion. It's been around since about 1998, so it's a lot more tried and true, relatively speaking, to something like Fusion. And it is still, to this day, a license it, buy it and use it. There's not fees and levels and stuff. You just kind of buy it. It's about $1,000. It's not cheap, but if you use it a lot for years, that's potentially a better deal for you than something like Fusion. And then, of course, there's Blender, which is free, kind of different, but can do very similar things. I hate getting into 3D package wars because they're silly, but there's a lot of options out there. You can use OpenSCAD, you can use this, you can use that. I happen to use Rhino, and mentally the model of how it works for me. So I don't know if that's a pros and cons list so much as that's kind of what it is. Let's see, what else do we have? Questions that I can't answer. Adafruit I/O is not working. Devices are not connecting. Something about ISS certificate update. I would head to either the forums or help with projects or help with Adafruit I/O in our Discord. You go to Adafruit forums, or you can go to the Adafruit Discord. Let's see. All right, so it seems like people would love to make this example I was trying work on the Circuit Playground Bluefruit there. So let's do this. I believe the questions were, how do we get that little list of pixels to light up a certain color? And let's try this. Someone said you can take, will that work? Take the color we want to use and multiply it by 4. That'll work. 1, 2, 3, 4. These kind of lists So 4 through 8 is actually 4, 5, 6, and 7. It does not include 8, so that's why I used 4 there. Other suggestions you could, if you didn't want them all to be the same color, I'm assuming we could do, let's do 3 of them one color, just for expediency. Bump, 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 and make this one green. So 1, 2, 3, 4. So you can make this sort of list of colors to work from, and of course there are more sophisticated ways to do this than just kind of one line like that. But yeah, okay. So if it looks like a lot of different ways this will work. Thank you everyone for posting your ideas on that. I appreciate it. It is so easy for me to get confused by tuples with commas and parentheses and commas and different brackets, but we did it. So thank you. Let's see, Tyeth Gundry in the Adafruit, rather than the YouTube chat, said the Adafruit IO SSL certificate change. It's the 20th, i.e. today, that it was going to be transitioned. Probably just need to update your code firmware libraries to the latest copies. Oh yeah, not ISS, SSL, nanogear. So I didn't know that, but yeah, if your certificate changed, then you'll probably need to refresh some stuff and update your code to use your latest. You should be able to go to Adafruit IO to your account settings and grab the new SSL certificate. Let's see. Oh, DJ Devon 3, you thank you. Yeah, DJ Devon 3 said, appreciate that I'm making the parsec snippets available now. I have a GitHub repo, and if you look at the 1 minute version or 2-ish minute version of Circuit Python parsec, there's a blog post and a YouTube video. I now have a link to my GitHub repo that's just that week's code.py. Nothing else, nothing fancy, no explanations. But if you look at the video and you want to copy the code, you can grab that. Now, the nice thing is that since I'm now broadcasting in 1080p most places, the code itself should be clearer if you're looking at this. That should be pretty clear. You sometimes can even snapshot it and then copy and paste it later out of your snapshot, out of your screen grab. At least on Mac OS, it'll do a pretty decent job of optical character recognition from a screenshot if you put it into notes or send it in messages. Paul Cutler says we're going to start linking to the GitHub repo in the weekly newsletter too. Oh, that's great. Very cool. Thank you for that. No pressure. Gosh, I liked that you didn't have my code to copy before because it could be messy, but now I got to give it a double check. Let's see. Pen Pengu said, I wonder if you could use slim enough latching push buttons so you could still store the finished music box drawer inside of the Mope shelf. I like that idea. Retractable, what if we had retractable, all those toggle switches could be neat. DJ Devon says, screenshot to OCR sounds cool. Don't think Windows snipping tool does that. There may be, yeah, I don't know, there may be third-party tools that do that. But it's definitely cool that it'll screw up a lot of spacing, tab, certain letters, O's will become zeros. Like it's pretty dangerous for code. You can spend more time trying to debug the copy paste than if you just transcribe it yourself sometimes. It just depends. Okay, I think that's it. I think that's all I've got for you today. So I will be working on, I've got my trusty ruler and caliper in one of the small drawers, so I'll be working on building that model inside of my my CAD drawings so that I can match them up there, cut this out, put the electronics in there, and now I've also got to get cracking on testing out my streaming of the WAV files off of the micro SD card. So that'll be next. Hopefully I'll have some of that to show you next week, so please come on back. I will remind you again, the unpronounceable to me, my apologies, coupon code this week is MOPPE, MOPE. That'll get you 10% off in the store on anything you want to grab that is actual physical goods and stuffs. If you head on over to the Adafruit.com and just put in /free, you'll see the incentives that we have for different buying levels. So if you spend $99 or more, you will get a free PermaProto half-size breadboard. If you order $149 or more, you'll get the breadboard and a KB2040. $299 or more, you get the breadboard, the PermaProto board, the KB2040, and a Circuit Playground Express. You will note we don't have the free ground shipping UPS happening right now due to the UPS strike or impending strike, so that's no longer on the table for the freebies, but the other stuff is pretty good stuff. So go check that out and buy yourself some cool things to build cool stuff. That's our motto here. Okay, I think that's going to do it. Thank you everyone for stopping by the show today. I will be back on Tuesday with a product pick of the week. We will have 3D Hangouts on Wednesday. We'll have Show and Tell Wednesday evening. We will have Ask an Engineer after the Show and Tell. I've left off, I'm sorry, I've left off on Fridays. We generally have Deep Dive with Foamy Guy, and sometimes a Saturday bonus stream from Foamy Guy on his own YouTube account. So stay tuned for all of those good things, and look forward to seeing you around. Thanks everyone. For Adafruit Industries, this has been John Park's Workshop. Bye-bye. Now with proper song.
Sorry.